right with once again? All right, so scientific notation was our problem of the day portion of our class. Now we're going to move and we're going to change gears. And we're going to talk about rate of change. That's your title of your lesson for today. So somewhere on your paper, go ahead and write that down. Rate of change. As you're writing rate of change, think about what that could possibly mean. Rate of change. Think about what it could mean. Now, you are in a math class, so make sure it applies to math. And when you have an idea that you would like to share, raise your hand and we'll listen. All right, Dakota, go for it.
I'm not sure what it is. I think it's like the rate in which like numbers and problems could change.
So
how much they change and how little they change.
So basically you're saying how numbers are going to change. Y'all like that?
Yeah.
Does that sound like it could be something?
Yeah.
All right, we're not going to write that down, but that's very good. Tevin, you wanted to say something?
Like, the rate means goes up or goes down. Like,
okay, something is going to go up, something is going to go down. What's going to make it go up and what's going to make it go down? Positives and negatives? All right, so what do you think we're going to be dealing with today? Like on a number line? Where else might we look at some rate of change problems?
A chart.
A chart? What else? A graph? So the number line, is a number line really a graph? Is a graph a number line?
Not really.
It could.
It can be? Okay, just curious as to how you feel about that. All right, so let me give you the definition and we'll see how good the boys were on point. It says how one quantity changes in relation to another. Go ahead and write that down. Rate of change, how one quantity changes in relation to another. Write that down for me. So from hearing that, were the boys kind of on the right track? Yeah, good job, guys. Rate of change, how one quantity changes in relation to the other. What do I mean by quantity?
Numbers.
Numbers, good. In relation to another. What does that mean? Kind of like what he was saying. If one number is going up, what could happen to the other one? It might go down. It could also go up as well, right? Okay. If one number is going down, the other one could what? Could go up or it could go down as well. All right, so you are correct. We're going to look at rate of change in the form of graphs, charts, and if we have time, well, you're definitely going to have time one day, but I don't know if I'm going to help you with it. It's going to be situational. Hope I spelled that right. Yeah, write those three down. So you can kind of have it's kind of like a little agenda that we're going to use today. We're going to look at some graphs, some charts, and some situations. And what I mean by situations, it's pretty much like a word problem, and you're going to have to like tell me what's actually happening in that part of the problem. All right? Now, there's one other thing that I want to give you right now before we go and start looking at some graphs and charts and everything else. We're in math, and I love formulas. Anybody else like formulas? Nobody? Don't like dealing with formulas? Formulas are easy to me because they tell you what you already have, basically. You just got to plug numbers in. All right, kind of like the equation, right?
Oh.
Make sense now? Okay. So I want you to write this down. Y2 minus Y1 over X2 minus X1. And that might look like a foreign language to you now. Some of you may have seen it before. You might recall it from when you learned this another day, another year. But that's going to help us later on. I just want to make sure you have it in your notes right now. Taking a look at that formula. Can you break it down for me right now? Can you tell me anything that you do see and know about it already?
I mean, like, by itself, no form. Don't end up by itself.
Well, it's going to end up being a fraction. Kind of. In the form of a fraction. Dakota? We might have to divide. Ooh, keep that in mind. Remember Dakota said the division. We're going to do that sooner or later. Anything else? What does this guy tell you? What's another word for subtract? To find the difference. So over here, we're going to write it's the difference in your y values. And at the bottom, it's the difference in your x values. Just keep all of that in your notes somewhere. Has everybody finished writing the word part, what I have? Hope so, because it's gone. Now, as you're writing that down, I'm going to tell you that there are two types of rates of change. Okay? The first one that we're going to look at is called a varied rate of change. What do you think that means? Varied. All right, if you're going to vary something, if something varies, what does that mean? Y'all know what the word vary means? All right, let me give you an example. Today I have on a dress. Tomorrow I'm probably going to wear Nike shorts and a t-shirt. The day after that, I'm probably going to wear blue jean shorts and a tank top. Is that varying, or am I staying the same every single day? I'm changing. So vary means to change, right? So if vary means to change, then what could be what would be the total opposite of that? To stay the same. All right, let's use the 8th grade middle school term, stay the same. What's the vocabulary word we're going to say instead of stay the same? Neutral? Okay. Another one. Starts with a C. Constant. Good. It's a constant rate of change. All right. Varied rate of change. Something is going to change. Constant rate of change. Something is probably going to give it to me. Constant is going to stay the same. Varied is going to change. All right. Good. On the right track so far. All right, well, y'all are finishing that up. I'll put this question up here on the board for it. And it might seem kind of juvenile, kind of elementary, but we're still going to take a look at it because it gives us a great example. All right, draw your attention to the smart board. And before you even read the words, I want you to take a look at the graph. All right, what are we talking about in the graph? Rate of change, but literally, what are we comparing? What are we talking about? Teddy bears. Anybody collect teddy bears or have teddy bears? No?
I have one.
You have one? All right, so this is, if you kind of look at the dates, you can kind of tell that this is a little bit old, right? All right, but we're still going to take a look at it. Look at your chart before we even look at the questions. You have two options right now. Varied rate of change, constant rate of change. If you had to choose right now, without knowing anything else about rate of change, which one would you say this graph resembles? Just give me your answers. What you got? Constant. You said varied. Who else said varied? You wanted to agree with varied. Lacey, what you think? Varied. All right. Varied people. Raise your hand if you think it's varied. And remember, there's no such thing as a wrong answer right now because we're all new to this. All right, hands down. If you think it's a constant rate of change. All right, who do you think is correct? You are?
Yep.
It is a varied rate of change. And what tells you the main reason that this is a varied rate of change?
It's just going up.
Because it goes up, but then what happens from here to here? Is it the same? Does it look the same here?
No.
No. So that's your biggest indicator that is a varied rate of change. All right, let somebody, Nigel, go ahead and read what it says under hobbies for me. Alicia is the girl's name.
Alicia likes to live teddy bears. With less than the number of teddy bears in her collection since 1997 and 2002.
All right, 1997 and 2002. Did everybody see 1997 on the chart? Everybody see 2002 on the chart? All right. Question number 1 says, by how many bears did Alicia's collection increase between 1997 and 1999? Then they want you to tell them about between 1999 and 2002. How are we going to determine what's actually going on here? How are we going to determine the increase? Subtract. What might be beneficial to us in determining what we're going to do? Anything? Your formula that I gave you earlier. All right? When I came in the classroom yesterday, y'all were talking about ordered pairs. Can you give me an example of an ordered pair that you see somewhere on this chart?
2002 and 30.
And 37. What's my X value and what's my Y value in that chart?
The
X value is 2002.
And my Y is,
37.
all right. Somebody else give me an ordered pair.
97 and
99 and 22.
37.
And the last one that you see is 19. Oh, my handwriting. 1997 and 8. Everybody agree that those are ordered pairs. You agree? They're also indicated by a little dot. Everybody knows how to graph those, right?
Yes, ma'am.
All right. So if I want to determine the increase between 1997 and 1999, which two do I need right now?
The bottom two.
The bottom two, all right? So I'm going to go ahead and erase this top one for right now. My apologies. Now, I'm going to go over here and I'm going to look at my formula. What's up with these little guys right here? Everybody ever seen those?
Yes.
You've seen them before? Do you know what they mean?
No.
Kind of forgot, maybe?
Yes, ma'am.
All right, I'm going to give you a hint. This is 1, and that's 2. This comes first, that comes second, right? All right. Which one would you probably say is the first ordered pair on this chart? Just which one would you think would be first? 1997 and 8. Why?
Because it has this, that's dot. It has the first dot.
It's kind of common sense, right?
Yeah.
All right. So where I have 1997 and 8, guess what I'm also going to put beside that X and that Y? A 1, because that's my X of 1 and my Y of 1. That's my first ordered pair that I'm dealing with. Everybody okay with that? You sure? So guess what I'm going to put beside this X and Y? 2. Everybody cool? You sure? All right. Everybody remember who your partner is from earlier? Go ahead and turn to your partner and very quickly, literally quickly, I want both of you to share your ideas and emotions, what you think so far about what I just told you about the 1s and the 2s. If your partner didn't quite get it, explain it to them if they don't know. Y'all ready? Discuss it. Go ahead and talk to your neighbor about what I just told you.
I didn't look up the one.
About 15 more seconds. Got it? Y'all got it? Y'all together? We okay? We okay? Good. My 2 groups over here. Julian's group, y'all okay? Good, good. All right. You were listening, and my time is up. All right, I hope you were listening, because guess what we're going to do now? We're gonna actually get to play with some numbers now, okay? We're going to figure out the increase between 1997 and 1999. All right, y'all ready for it? So, Y2 minus Y1. Somebody tell me what my Y2 is. Y2? Give me the actual number, Kennedy. 22. Write this down. What's my Y1? Y1. Alyssa? 8. Good. All right. Why am I putting it at the top?
Because they're
Because that's Y2 and Y1 on the
Because the formula told me, and those are my Y values, right? Hint, hint. Remember this. Y goes over X, okay? When you're talking about a graph. Just for future references. All right. X's. Somebody give me X2. The Lexus. 99. Therefore, X1 is going to be... Anything I can do with this right here, guys? Subtract. All right, go ahead and do so. 22 minus 8, what you get? 14. 1999 minus 1997. 2. Because that's 97, 98, 99. That's 2 years. I got 14 over 2. What did Dakota say earlier was that second? What was it? Divide. Now, 14 divided by 2, that's easy enough. 7. What does that 7 mean?
That's the answer.
That's the answer, all right? That's the answer. But what was the question asking?
How many?
That's the what? Increase. Use your vocabulary. Good. Questions or concerns about that?
It increased by 7.
And that's 7 what?
7 bears.
7 bears. What?
Increased.
7 bears per what?
Per year.
Good. Now, why am I throwing all of this extra jibber jabber at the end? Why am I doing all of that extra stuff? We was fine with 7. Now she want to go and put words behind it. Why is she going to put words behind it?
What they're talking about.
Ah, so you know what they're talking about. You know it's an increase, but an increase in what? Right? It's an increase in bears per year. Where did I come up with bears per year though, guys? The graph. All right. Bears. Y-axis, right? Bears on the y-axis. Bears on top, the y-axis. Good. Years at the bottom. Questions or concerns about that first part? Did I fully answer? Listen up. Did I fully answer question number 1?
You gotta find between 1999 and 2002.
I gotta find between 1999 and
We
2002.
gotta find.
You're right. You all, on your own, you're going to finish solving question number 1. Everybody cool?
Yeah.
Got it?
Yes.
Tell me the increase between 1999 and 2002. I'm going to leave this on the board for those of you that need to go back and look at it. If you need some help setting the problem up, raise your hand. All right, let's get to work. 1999 and 2002.
That's how we define.
Yep, that's all you got to find for me right now. Now, if you think you're good like that, go ahead and answer the second question if you're good like that. Okay. Now, which one is first? 1999 or 2002? All right, so which one should be first? All right, now let's look. What I mean by first is which one is first here. So this is going to be your X1, Y1, X2, Y2. So you might have to do some rearranging on it. If you have any trouble, raise your hand. I'll come and assist you.
I didn't see them numbers.
You didn't see those? Let me erase this because I don't want this to confuse it. Those are the order pairs that you're using. Remember, how do you label X1 and Y1, X2 and Y2? That's the main thing. All right, now you might want to go back and look and see. Make sure it's the correct way. Make sure you set it up correctly. Let me check the answer again. Okay? Make sure you set it up correctly. What's wrong? You don't get it right, you answer the question. Why you answer the question? What you don't get? Okay, so right here, this was the first part of my question, right? Wouldn't you agree that this is the first point? And wouldn't you agree that this is the second? All right, so I'm going to call this X1, Y1. I'm going to call this X2, Y2. Now, for the part that you're working on right now, you're talking about 1999 and what? 2002. So which one will be X1 and which one will be X2? Which one comes first? And X2 is going to be, you got it now? So all you got to do is ask a question. Good job. Anybody else? 1 more minute because I don't want to lose too much time on our charts and our situation. Okay, it looks good. Let me go back and check. Between
That was weird.
99.
That's amazing.
Y'all know y'all are on the camera. Why y'all doing it?
Because it's a free country.
Y'all know.
No, we're not done.
Hey,
We're
calm
not.
down.
I
You're getting some different answers here.
don't know if this is right for number 2 though. I got that for number 1.
Okay, looks good.
What is it? I'm getting confused on my head.
On number 1?
Go back and check. Good.
It's 5, right?
What you got? Still working?
I don't know.
All right, who's ready to help me help you? Somebody tell me what X1 and Y1 is. X1 is, Julie, what What you got for X1? Is it 1999, 22, or 2002, 37? X.
2002.
All I want to know is, all right, well, let's do it like this. What's Y2 minus Y1?
30. 37 minus 22.
Good. All right, now, let me tell you where that came from. I know you know how to get it, but let me just show you one more time. This is X, and that's Y, correct?
Mm-hmm.
This is the X1, and that's Y1, because they are first. They come before this one, right? So it's first. This is X2, and that is Y2. That's why that's 32 minus 22. You got it now?
Mm-hmm.
All right. Julie, help me out with the bottom.
2002, 1999,
All right. What you got for 37 minus 22?
15.
15. Good.
3,
3. Basic division. How many you got? 5. 5 what though?
Damn.
5 bears.
Bears
Bears. Per year.
per year. I'm going to do the fraction symbol like that. Anybody have any time to go and look at the second question?
Yep.
Between which years did Alicia's collection increase the fastest? Which one increased the fastest?
I say 1999 to 2002.
You think so? All right, what did we get for 1990 to 2002?
That's wrong.
5 years.
That's wrong.
The one we did together, what we got?
Oh, it's not.
7. So what should be your answer, Chris?
1997.
1997 to
1999.
1999. Because 7 is bigger than 5, right?
Mm-hmm.
I would rather have $7 than 5.
Yeah.
All right, questions or concerns about looking at varied rate of change in the form of a graph? You got it? How many think you can handle in the form of a chart? You know what a chart is? No? Yeah, you do. Let me show you one. We're going to do this one very quickly. I'm going to keep my little formula up here. Should still have it in your notes. All right, we're going to talk about your age versus your height. All right, age is measured in, of course, years. And here they measure height in inches. So we have 8, 11, and 13. And when you're 8, it is 51, 58, and 67. $51, 58, and 67. I want you to show the rest. Our directions tell us to find the rate of change. I'll abbreviate rate of change between ages 8 and 13. Find your rate of change between ages 8 and 13. Yes, ma'am. Come on, ma'am. All right. Am I still going to be able to use my formula over here probably? You think so? Yes or no? You think I can still use it? Do I still have ordered pairs? I do? All right. What are my ordered pairs? 851, 11 and 58 for 11, and 13 and 67. Now, I don't need the 11 for right now, okay? How am I going to set it up? Which one is my X and which one is my Y? I want you, right now, to go ahead and set it up on your own paper to see if you can figure it out. Which one will go on top and which one will probably go on the bottom? Think about it. The ages and your heights. Go ahead and see if you can set it up on your own. How do you think it would look? X or Y?
I put X.
It
For
is
X.
X. Height. Y values. If you need to change your answer, go ahead and do so. Some of you might just have to flip it if you need to. Let's see. Should be. Nope. Now let's look. Which one is X and which one is Y? He said this is the X and that's the Y, so you need to do what to it? If this is the X and that's the Y, you got it? There you go.
Wait, so it's on the bottom.
What goes at the bottom? X's do go at the bottom. What goes up at top? Y.
Oh, yeah.
Looks good. We'll see. I'm not sure the exact answers. Let's look at it again. Remember, X is at the bottom. Y is up top. I gave you your X and your Y. You figure out which one goes where. Your X and your Y. Where is it? Oh, let's see. All right. Okay. Now put it in the form of so you can do your subtraction and your division. How? No, you don't know. All right. Let's see.
You want to do all three of them?
Now which one is of course going to be the X1?
50.
Okay, so we'll throw your marker away.
Okay.
Yes or no? Did I do that wrong? I put it on the wrong one. Did I?
That's right.
Good. Put yours on the board for me. All right, what's wrong here? When you subtract that, what are you going to get? 58 minus 67. What kind of answer are you going to get? I have the marker, I'm sorry. What kind of answer are you going to get? Have we, should we get a negative number up here?
No.
No. So if you do get a negative, you probably have it, what?
Backwards.
Backwards. Good. You need to get a calculator if you can. Good. You changed something. Good. Good. All right. Look right here. Look at that part again. 8 minus 13 is going to give you a what?
Oh, and negative.
16 divided by 5. I think you made one small error,
It's 3
Chris.
points.
You put a 1.
Oh, not bad.
Come back and look at that. Come back and change that. Good. Where we at? Can you do your subtraction? Good. 16 over 5. 3 1/5 looks a lot better than 1 1/5.
Not bad.
Why did he put 67 minus 51 at the top? Who can tell me one more time?
That's the Y values.
Then the Y values, your Y's go on top. And 13 minus 8, he got 16 over 5. He divided 3.5 or 3.2. Which one? What's 3.5? Decimal equivalent.
3.2.
What's 3.5 decimal equivalent?
3.2.
3.2 is the same thing as 3 1/5?
No.
What's
Yeah,
3 1/5?
Wait, what?
3 1/5 is 3.2, but 3.5 would be 3.
We were right.
Ah, so if I
I
reword it,
was right.
Yeah, I
Yeah.
thought you were wrong.
I was not getting my answer.
I know, I didn't say I was wrong. I was saying the different way. All right, so questions about looking at rate of change in a graph or in a chart. In a graph or in a chart. All right, I want you now to find the rate of change on your own between the ages of 8 and 11. Can you handle that part?
Yes, ma'am.
All right, we did 8 and 13. So now I want you to find 8 and 11. Is your setup kind of going to be the same? Yep, only thing that's going to really change are the numbers. And remember, you don't want to end up with a negative value. You're trying to find the difference.
Could you have a negative?
No, you will not have a negative. So if you find you get a negative, go back and look at it again for me. Okay, stop it for a second.